Okay, so this one looks fairly complicated, but it's just, well, it's a product, so we're going to have to use the product rule, and then inside of that product rule we have here a chain rule situation. Okay, so let's start off. So first we have, remember, you get the derivative of the first, so the derivative of this guy is just 2t plus 3 times the second, leaving it alone, so we have 1 minus e to the minus t squared, okay, plus the first, leave it alone, t squared plus 3t, times the derivative of the second. Okay, so the derivative of the second is, well, the derivative of 1 is nothing, and the negative, well, imagine this is a negative 1, so we're going to leave it out of the derivative, and the derivative of e to the negative t squared, well, remember, the derivative of the exponential, the natural exponential, is just itself, leaving the inside alone, and then times the derivative of the inside. Well, the derivative of the inside is just negative 2t. And so that's the derivative. And these two negatives can turn into a positive, but that's pretty much it. Okay, so here we have our very first multi-level chain rule. So far we've only had 2 levels, which is the simplest case. But notice here you have the most outside function, which is 2 raised to a power. And then in there you have another function, which is e, which also has its own inside. So this is a composition of 3 different functions. And so then this is where the analogy of the Russian dolls comes in handy the most. Okay, so let's get right to it. So first we have the derivative of the most outside. Well, the most outside function is the red one here, 2 to the e to the 3x. So the derivative of the exponential functions, remember, is just themselves, leaving the inside alone, times the natural log of the base, which is 2 in this case. Okay, and then you go in one level, now to the black, and we're going to get the derivative of the black function. So the derivative of e to the 3x, well, that's just, remember, itself, leaving the inside alone, and then times the derivative of the inside. So the derivative of 3x is just 3. And so that's the process that you use to find the derivative of a composition of more than 2 functions. Okay, so this one is a bit more complicated because we have here the outside function is this entire thing being raised to the 9th power. And then inside, though, this one isn't very complicated, but here we have a product rule situation where we have to get the derivative of these guys. Would take us a little bit more time. Okay, so, but this is nothing that we can't do. So the first thing that's going on is the outside function. We have this whole thing raised to the 9th, so we have 9 times t. Remember, you leave the inside alone, so e to the 3t plus e to the 5t. And then subtract 1, so the whole thing to the 8th. Okay, and then now we move inside, so we get the derivative of the inside. Well, when we get the derivative of this very first chunk, we have to use the product rule. So to do the product rule, we get the derivative of the first, which is just 1, times the second, leave it alone, plus, now the first you leave it alone, which is t, times the derivative of the second. Well, the derivative of e to the 3t, that's itself, times the derivative of the top, which is 3. Okay, so that's the product rule for this first part, for this very first part. And then plus the derivative of e to the 5t. Well, that's just e itself, e to the 5t, times the derivative of the top, which is just 5. And that's it. We're done. So see, it's not that bad. You just use the Russian doll analogy and you can do as many as you want.